So for our last video, we have been doing compositions with a function and their inverse or different order. Now this will be, maybe we're going to compose different functions, right? Like this is like C's being tangent composed with inverse cosine. So we're going to up the ante a little bit. So A looks somewhat familiar. We've done something like that. So again, bringing back that beautiful unit circle. It's your best friend in here. 7 pi over 6 is here. Okay, well, inverse cosine, refresh your memory if you need it, can only live here and here. So I definitely can't list 7 pi over 6 as my answer. But you can think about, all right, well, what does cosine produce here? Negative root 3 over 2. And where it can live, where else does it produce negative root 3 over 2? And that's right here. And so that's why I'm going to say 5 pi over 6. And then again, I'm going to use this reference angle so it gets better and better for you. If I wanted to use that idea here to here, that's my reference angle, which would be pi over 6. So you make the decision, do you go here with your reference angle or do you go here? Well, my cosine produces negatives, so I need to go here. So that angle is pi over 6 from this part, and so that's why this whole angle would be 5 pi over 6. Now this one, B, sine composed with inverse cosine of 1/2. Let me go ahead and get this beauty back. And this one, there's a couple different ways we can do it. One is we just use our unit circle. So sine, we just find where cosine produces 1/2, where it can live. So positive 1/2 for cosine is right here. So that angle is pi over 3. So it's, you are evaluating the inside. So it's like, order of operations, evaluate the inside of parentheses and then keep solving. So you just evaluated what inverse cosine of 1/2 is, and it's pi over 3. And what does sine produce there? Well, root 3 over 2. Now that's really convenient when it's on your unit circle. However, say another way you could do it is go ahead and create a right triangle. You don't know what the angle is, but cosine is producing 1/2, and that is adjacent over hypotenuse. It's a right triangle. Do Pythagorean theorem. I'm going to save us a little time. That becomes root 3. And what do you know? Sine of this triangle is root 3 over 2. And that's what is happening in your unit circle, which just makes it easier to find when you have your unit circle to look at. So like C, when I'm looking at C, tangent composed with inverse cosine of 1/3, there is no 1/3 on my unit circle for cosine or sine or tangent. So that's where you're a little stuck. So like I always say, when you're stuck, create a triangle. Cosine's positive, so I'm going to put it here. I don't care what this angle is. This thing produces an angle, whatever it is. I don't care what it is. But from that angle, the definition of cosine is adjacent over hypotenuse. If you do Pythagorean theorem, so I'm going to label this y since it's a vertical movement. So I could do 3 squared plus, or nope, that's not true. 3 squared equals y squared plus 1 squared. 9 equals y squared plus 1. So y squared equals 8. Take the square root, but you always have to simplify. So we get 2 root 2. So tangent of this triangle is opposite over adjacent. So we end up getting, I should have wrote that a little further down, just 2 root 2. So you can always use that method, or, you know, like D, that's actually going to be on the unit circle. So maybe the unit circle makes it a little quicker. So D, sine composed with inverse cosine of root 3 over 2. So I'm looking there. I can find inverse cosine of root 3 over 2, and that is right here. And that angle, so this one's easier because I can find the angle. Here I couldn't, but I just used theta just to be its placeholder. So sine of pi over 6. So I just evaluate what's inside those parentheses and then find sine of pi over 6, and that's 1/2. Again, you can use that right triangle business too. All right, a couple more. Okay, so this one, E. Now I'm introducing good old cosecant. That's fun. Well, this is cosecant composed with inverse tangent of -2. And if you even, I'm going to make us a little dizzy. I'm going to go all the way up to inverse tangent where our chart is here. There is nowhere where it's -2, but remember, it produces all reals, right? There's a lot of things happening in between those values. Those are just some key points with our special right triangles. So I'm going to go down here. So it does happen. So what I'm going to do is, I'm stuck. I'm going to create a triangle. Well, since tangent, arctangent of -2, it's a negative value, I'm just going to get in a good habit of creating my triangle where it would be. Because remember, arctangent can only live here or here. If it's negative, it has to be in that fourth quadrant. This is some angle. That's what this thing produces. I don't care what it is. But the definition of that is, well, my tangent is opposite over adjacent. Since it's -2, it's understood to be -2 over 1. Good old Pythagorean theorem. So I'm going to just save us time because I'm hoping we're getting good at that. This is just root 5, my hypotenuse. Well, what's the definition of cosecant? That is the reciprocal of sine. So cosecant would be hypotenuse over opposite. And you're done. So I'm going to let you all try F on your own. Okay. And then now we're going to get to the last two, because F is similar to E and C, actually, and a little bit like B, but it's just not on your unit circle. So I just want to see if you can come up with it on your own. Now the last two, they're abstract. Oh, I gotta finish. So we have cotangent composed with arc sine of 3x over 5. So it's a similar process, right? It's just we have this variable there that might shut us down, but hopefully it doesn't. Again, this thing produces some angle. I have no clue what it is. But I'm just going to put arc sine, my triangle here, because my arc sine, my input's positive. Opposite over hypotenuse. So now this, I don't know, but I can't figure it out with using Pythagorean theorem like I've done before. I don't want to use x as my variable since I already have an x. So sadly, that is an x movement, but I'm just going to go ahead and use, let's use something that we're not used to. Shoot, why can't I think? I'm just going to use a good old h. Just randomly choosing an h. Okay, so if I set this up, it's h squared plus the other side squared equals 5 squared. All right, h squared plus 9x squared equals 25. Okay, so your goal is to solve for that h. So I take away the 9x squared, okay? And then you take the square root So h is the square root. It's ugly, but that's what it is. So I'm going to go ahead and replace that with this 25 minus 9x squared. Okay, so now cotangent, remember, that is that idea of the reciprocal of tangent. So that definition is adjacent over opposite. So my adjacent is root 25 minus 9x squared over opposite. Now, when you take a square root, it's plus or minus, but realize we're in the first quadrant because this thing was positive, so it's just the positive one of it. And you can't reduce that thing anymore or simplify that radical, okay? Those are terms, so I can't take the square root of them individually. So that thing is done. All right, let's do one more. Make sure it's sitting well with you. So tangent composed with inverse secant of that beautiful thing. Once again, I don't know what this thing is producing, but it produces some angle. We haven't talked about limitations for inverse secant and inverse cosine and all, cosecant and cotangent. It's not part of our curriculum. So, but you don't need to know it when you are going ahead and finding these things. So because it's positive, I'm going to go ahead and put it in the first quadrant. Here's theta. Okay, secant's definition is the inverse for cosine. Reciprocal, forgive me, reciprocal, not inverse, different things. Reciprocal for cosine, which would be hypotenuse. Hold on one second. Reciprocal for cosine. So that means that this is your hypotenuse, this root 9 plus x squared, because it's hypotenuse over adjacent. Okay, well now you need to find y. Luckily I could use y. So once again, set up, let me change colors so this stands out. X squared plus y squared equals root 9 plus x squared, and I square that whole thing. All right, well, again, your job here is to solve for y. Well, if you square this whole thing, that just gets rid of the radical. Solve for my y. So I'm going to take that x squared over. Ooh, this is fun. So then y squared just equals 9. Take the square root, y equals 3. Now tangent of this triangle would be opposite, which is 3. That's opposite your angle, over adjacent. See you in class.